Hello community! Let's have a look at visual mathematical reasoning by AI. And you might say, hey, wait a minute, does it mean when I have here some exercise in a textbook, in a mathematical textbook, and I just see here the visual mathematical problem in front of me, I just need to ask here on my iPhone some large multimodal AI system, and I will be presented with the complete answer? Yes, exactly. But today we're gonna experience and have a deep dive how the reasoning is happening and how we can test different models for their performance, so you know what model you should choose if you are sitting at the university and you get here your exercises here that you have to solve. So let's start. We are talking about large multimodal models, and the topic today is Remat. And this is designed here by a research team to explore how LLMs solve problems. Now, you remember here in my last video where I showed you how large language models solve these problems. Now we draw upon how the humans tackle problems incrementally by leveraging fundamental knowledge concept, break down complex mathematical problems into simpler mathematical subproblems. And if you want, you can say today's video is a continuation of my last video. And today we look here at a vision plus an LLM plus a math solving AI system combined in one. Isn't that beautiful? Now, I have to tell you, I just found out today that after my last video, here we have a post by Philipp Schmidt. And if you want to see the internal reasoning, Anthropic Claude 3.5 Sonnet with the command, hey, from now on use paragraph instead of parentheses, you can see the internal reasoning step of Sonnet. So thank you to Philipp Schmidt. Maybe you go there, maybe you subscribe to him. He's, I think, a technical lead at Hugging Face, so a great idea to subscribe to Philipp Schmidt. And he says, yeah, if you do this command, you see the internal thinking. And let me show you this maybe in a little bit more detailed. So you have then suddenly here paragraph on thinking and paragraph on thinking stop. And you see here that Claude Sonnet thinks, hey, this task involves creating a Python script to calculate the planetary distances, which is a good candidate for an artifact. And I show you the artifact here. It is substantial, self-contained, and likely to be reused or modified. I'll create a new artifact for this. And then we can see how Sonnet is thinking. We have now the creation of an ant artifact, and you do not see this normally. But if you put in here this command from now on use paragraph instead of parentheses, you can see this, the internal reasoning process. So you have here an ant artifact. You have an identifier, planet distance calculator. You have a type of an application to write code. The language is Python. And the title for this particular task is Earth Mass Distance Calculator. And then you import here the math module and you define here your first function. So you see, we see how Sonnet is thinking. And this is a beautiful thing that you can do this yourself. But hey, we are here about visual, mathematical, large multimodal reasoning here. So let's have a look at this. So yeah, exactly. We have a textbook and we see an exercise in a mathematical textbook, and we want that here a multimodal model is able to solve it and give us here the correct path forward how to solve this, to teach us how we can do those things. Now, as I showed you, we have some new research here. They called it Remat. And they here categorize here mathematical problems into simple 5 distinct types. They have here plain figures, understand here the plain figures, calculate here the figures like rectangles and whatever. Then we have measurement, angles and length. Then we have solid figures, understand what is a solid figure if you see this image, for example, and then all the calculation that goes with the solid figures. We have transformation and motion of figures. Basic transformation of figures, like you have a mirror function, or you had cutting or combining figures, folding figures. We have position and direction. Think about a GPS map, direction, position, your car. So you see some beautiful examples. And those 5 categories that I showed you here can be decomposed, further analyzed into 12 typical problems. I'll show you this in a second, which are further decomposed, detailed as 67 knowledge concepts. And we will look at this particular data set, and I will show it to you. And here we have the research team, beautiful, and they published this on 1st of July 2024. Remat. Does your large multimodal model achieve human-like mathematical reasoning? And to tell you here the result, not human-like, but interesting results. Let's have a look. So what they did, they collected samples, so they collected here 6,307 images of mathematical test questions. And they now created newly questions out of the 6,300 images, and they got about 6,500 questions. Remember, 6.5K questions. Great. Now they say, hey, it is evident that assessing just the final answer will not give us an insight into the reasoning process of a multimodal model. Therefore, we probe here the model's ability to solve composite mathematical problems with K knowledge concept into 2 stages. At first, we see if our LMMs can solve here K, 2, 3 individual mathematical subproblems corresponding to its knowledge concept. And then we see, can an LLM reason out a final answer by integrating now, let's say, 3 individual knowledge concepts together, and the original thing is more than just the sum of its parts. Beautiful. Here you have now the absolute breakdown. So you see for all the different concepts, like say here position, this is this one here at position and direction, you have now the subtask front-back position, up-down position, and left-right position. And for example, here the basic transformation of figures, you have an axial symmetry, a translation, and a rotation of those. And here you have all the further defined details. And you might say, how was it possible? Who did this? And you are not going to believe who did it. It was humans. So much about AI. So all the problems, you remember, 6.5K in Remat are sourced from publicly authoritative mathematical websites or books that are online and subsequently organized based on our defined knowledge structure that I just showed you, the beautiful circle. And then they employed 3 human expert annotators to manually label each question with the knowledge concept and then to cross-validate, so to ensure that at least 2 experts have identical annotation for the same questions. So those 3 professors of mathematics really enjoyed their time. Great. But then they wanted to categorize, like in my last video here, the subsequent decomposition of our, remember we had a D3 problem in the last video, now of this mathematical problem, and they also go here with 3 classes, a 1-step solution, a 2-step solution, and a 3-step solution. And they want to have this simple categorization to get a deeper understanding on how large multimodal models solve mathematical problems. So you see, a lot of human work goes in here to evaluate the mathematical performance of our models. Now, to create the data set, and I'll give you the link to this data set, we have now a mathematical reasoning task. So we have a number of questions, we have a number of images and the corresponding answers that were all annotated by the human annotator. And this defines now the evaluation data set, D for data, evaluation for evaluation. And here we have our questions, our images, our answers. And then we have here certain constraints that we imply. So we have now here Ki and Ci, 2 prior constraints for the question. Ci represents here the prerequisite conditions needed to solve the problem. And Ki denotes here the knowledge concept within the questions. Great. If you want to get familiar with the scientific notation from our green grasshoppers, here is exactly what each symbol means in this mathematical notation. And then we want to decompose these mathematical problems into multiple simpler problems. You're not going to believe this? Yes, this is exactly what's going to happen. Great. Now, they classified now the response of our LMMs into 4 categories. They said, okay, so what happens if you get an answer and we see one open source model AI system here has insufficient knowledge? This means now that part of the one-step mathematical problems contain errors. And the multi-step reasoning problem in mathematics is also wrong. So we see here the model's insufficient grasp of a single knowledge concept may lead to errors in the higher value, more complex multi-step mathematical problems. This is what happens a lot of. And then they look for inadequate generalization. And they say this happens when all one-step mathematical problems are correct, but the multi-step mathematical problem is incorrect. So this shows us now that our AI system, our LMMs, are capable of understanding individual knowledge concept, but they struggle to generalize that knowledge to solve more composite mathematical problems. Then, of course, we have the best case, the complete mastery. All one-step problems are correct and the multi-step problem is answered correctly. System is just perfect. And then the absolute opposite here. So we have here route memorization. So the one-step problems contain errors, but the multi-step mathematical problem is answered correctly, which simply contradicts the human logical thinking, and this indicates that the solution was maybe memorized but not understood in its particular parts how to solve these problems. So you see, insufficient knowledge, inadequate generalization, just perfect mastery, and something goes wrong. Now let me give you an example after all this theory. It is easy. We have a 3-step problem. And you have here a flower, something, and Mary walks from the northernmost point of a circular flower bed along the edges to the easternmost point, covering a distance of 50 meters. So we have here Mary. Mary starts here in the north and goes down here to the east. She's here on a circle. And now, if I tell you that here, this distance she covered is 50.24 meters, what is now the area of the flower bed in square meters? Now, we have now the human reasoning and we understand that this is a 3-step problem. So step 1, we have now the direction east, south, west, and north, you know this, and I can calculate the angle of the distance traveled based on the easternmost and northernmost point, and the human understands, so the angle between those points is 90 degrees. Great. Step 1. Second step, if I know that the angle between those points is 90 degrees, and the distance here on this circle is exactly 50.24 meters, I can calculate the radius of this circle. And if this is step 2, and step 3 is, if I know the radius of a circle, I can calculate the area from the radius. So you see, easy task. Human would say 1, 2, 3-step problem. Solved. Beautiful. This is exactly now what we want that the AI system is able to do. You have here again the human reasoning, and you see exactly the decomposition is exactly here the same. What is the measure of the angle in degrees? Well, 90 degrees. What is the radius? You can calculate the radius. And if you have the radius, you calculate the area of the flower bed in square meters. And they did this for a lot of examples so that they have enough evaluation data in their data set. And they found here now that this insufficient knowledge, the very first one that I show you, as a foundational challenge here in the mathematical reasoning. A lot of open source models fail here in the insufficient knowledge step. And to heuristically tackle this issue, the researchers here enlisted another human expert, what a surprise, to help here the creation process, the augmentation process, the reasoning process to come to the solution. They created now 67 knowledge concept cards. And on these cards is written down here the reasoning process. So if the AI systems fail, they have here the cards to check, hey, there's the solution on the card. And expert annotators, another time humans, offer here precise summary derived from Wikipedia and textbooks and everything. You know this. So on these cards, you have now the crucial knowledge, the hints for the AI to solve these problems. Great. Let me show you one card that you get a feeling. What is it? Now, for example, for cutting and combining of figures here, we have now the folding problems. And now it describes here exactly what happens, or the division of plain figures. Gives you an exact description what is happening, what are the characteristics, how to do it, and so on. So you have, if you want, sheets that explain now, in addition to the knowledge here, everything. So if you have those sheets, you can test now your LMM. And here is the final result. Here you have here the, if you want, proprietary models, GPT-4 Omni, yeah, GPT-4 Vision, yeah, Gemini 1.5 Pro. Finally, some actual model data that we have here. Plus here, everything that they think is open source. And then you have it for a one-step mathematical problem, a two-step mathematical problem, and a three-step mathematical problem here, the indicators, the performance indicators. And then, as I told you, we have 5 layers, and for those 5 layers, 1, 2, 3, 4, 5, they give you here the exact data, and even for the further subdivision of the data, you have here all the data, and not surprisingly, GPT-4 Omni is here the best model. Great. But it tells you, if you have a specific problem, let's say here, in this particular case, now you can choose, or you see that this model here, the GLM for Vision, 9 billion pre-trainable parameter, is from the open source models the best performing in your specific category. So if you know what task you have to choose, you see this has 19, let's say, percentage point success, but this has 50. So this is nice. This gives us now a deep insight into the capabilities of our large multimodal models. Great. Please note here, this is not the latest 5.3 Vision version, because 5.3 was updated just 2 days ago of recording this video. And also for DeepSeek, we have now a Vision 2. So remember, always check also the version, the specific version here. But you see, there's a lot of performance difference here, especially in the open source models. Great. If you want to see this here in a visual representation, the same data here now, you have here the best proprietary with GPT-4 Omni here. Yes, you see here really excellent results. Then you have the big open source model and the little tiny open source model down to 1.3 billion free trainable parameter. And given here the specific task, you see here the performance of your LMM. We have 3 main messages. They identified here the inadequate knowledge issue as the greatest vulnerability of our LMMs. So those LLMs cannot simply solve a one-step mathematical problem. They fail on the one-step level. Plus, the rote memorization issue remains widespread across most LLMs. Completely nonsense. This AI system is just going, let's call it, unreasonable, crazy. And however they say, but one system, of course it was GPT-4 Omnis, their main challenge now has shifted away from the inadequate knowledge to GPT-4 Omni is now fighting with the next step with inadequate generalization of one-step mathematical problem solving. So you see, one little LMM is trying to get to the next step on the ladder of complexity, and it is now entering here the domain of inadequate generalization. Great! If you want to see this for yourself, I recommend you have a look here at Remat GitHub.io. You have everything, the archive, the complete code, the dataset. You have here, they have a Twitter account, great, the knowledge card, have a look at this. I will use their dataset and maybe part of the knowledge card for the fine-tuning of my models, because I think if you are interested in science, and science is a topic for your AI systems, if you have detailed, more than 6,000 detailed mathematical problems solved step by step in a one-step, two-step, and three-step solution pathway presented, these are some valuable information also, I think, for the pre-training and the fine-tuning of my models. But just want to tell you, use those data sets that are generated by the community if they're open source, because it can make your life so much easier. Anyway, I hope it was informative. I hope there were some elements for you in this video, and it would be great to see you in the next video.